Ever wondered how your computer makes decisions? Today we're diving into the heart of C++ logic to solve a classic problem. Welcome to this full tutorial on reading numbers and categorizing them as positive, negative, or zero. By the end of this video, you'll not only have the code, but a deep understanding of how conditional statements work in real-world programming. Before we touch a single line of code, let's look at the logical flow of our problem. We have three distinct possibilities for any number. First, the number could be greater than 0, which we call positive. Think of it like a bank balance going up. Second, the number could be less than 0. In our code, this represents negative values, like a temperature below freezing. And finally, the number could be exactly 0. This is our neutral point, neither positive nor negative. In C++, we handle these branches using the if, and else keywords. Let's start building our program environment. Every C++ program starts with headers. We use iostream to allow our program to talk to the user through the console. Adding using namespace std saves us time, so we don't have to type std::: before every input or output command. Now we define our main function. This is the starting point where the operating system begins executing our code. We'll declare a variable named num. We use the double type so our program can handle both whole numbers and decimals. Communication is key. We use cout to ask the user to provide a number for us to check. The cin command captures the user's input and stores it safely inside our num variable. Now the logic begins. Our first check, is the number greater than 0? We use the if statement followed by our condition in parentheses. If that condition is true, the code inside these braces runs and the word positive is printed to the screen. But what if it's not greater than 0? We move to our secondary check using the else if statement. Here, we check if the number is less than 0. This catches all our negative values in one net. If the number is indeed negative, our program responds by printing negative and skipping the rest of the checks. Finally, we have the else block. This is our default case. It only runs if both previous conditions were false. Since any number that isn't positive or negative must be 0, we simply print 0 here without needing another check. We finish with return 0 to tell the computer that our program finished successfully. Let's see the full code together. Here is the finished script. It's clean, efficient, and handles every possible numerical input correctly. Let's trace it. If we enter the number 5, the first check finds that 5 is greater than 0. Success! It prints positive. Now try -10. The first check fails, but the else if check sees that -10 is less than 0. It prints negative. And if we enter 0, both conditions fail, so the program defaults to the else block and prints 0. Simple and effective. A common tip for beginners, remember that conditional statements check for truth. While we used greater than here, always be careful with equality. Don't forget the parentheses around your conditions. These are required by C++ to define where the check begins and ends. And always use curly braces to group your code. Even for a single line, they make your code much more readable and easier to debug later. This logic is the foundation of complex software. Whether you're building a game engine or a database, these checks are everywhere. Quick test. What happens if you enter 0.0? Because we use the double type, it's handled perfectly and prints 0. You could also use nested if statements, but the if-else-if ladder we built is much cleaner for this specific problem. Conditional statements like these are incredibly fast, allowing your computer to make millions of these decisions every single second. For simple cases, C++ offers the ternary operator, which is like a one-line if-else statement. It works like this: condition, question mark, then the result if true, and a colon for the result if false. Very concise. You might also see switch statements in other tutorials. However, switch is designed for discrete values, not numerical ranges. Since we are checking if a number is greater or less than 0, the if-else-if ladder remains the best choice for this specific problem. Real programs need to handle mistakes. What if a user enters a letter instead of a number by mistake? We can use cin.fail to detect invalid input and tell the user to try again, making our program robust and professional. Another common mistake is placing a semicolon immediately after the if condition. This effectively ends the check prematurely and runs the next line anyway. Later, you can combine checks using logical AND or logical OR to create even more complex decision-making rules for your software. If your code isn't working, use cout statements to print the values of your variables at each step of the logic. This is called debugging. This pattern of if, and else can be extended to as many branches as your logic requires. It is truly scalable. Think of a thermostat. If the temperature is less than the target, it turns on the heat. That's the power of if-else in action. Or a video game. If your health reaches 0, it's game over. You're learning the building blocks of all modern technology. Let's summarize. First, we included our library and defined our main entry point. Then, we set up our storage. Next, we took input from the user. Finally, we used our logic ladder to decide which message to display. The best way to learn is to do. Try modifying this code to check for even or odd numbers next. You've just mastered one of the most important concepts in programming. Keep coding, keep experimenting, and I'll see you in the next tutorial.